Okay, so we're starting with the chapter Fun with Magnets. What do you see in the picture? Like picking up pieces of iron from waste. Why does the pieces of iron get attracted towards it? That is because there is a magnet which attracts the iron objects. You might have seen magnets and have enjoyed playing with them at home. You might have seen stickers getting attached to the refrigerator, the pencil box. So you might have seen many objects. Like over here we have a magnet and we see the iron nails getting attracted towards it. Now how were the magnets discovered? It is said that there was a shepherd named Magnes who lived in ancient Greece. So while he was taking his herd for grazing, he saw that a stick which had a piece of iron attached at one end, it started getting pulled hard from a rock. So it seemed as if the stick was being attracted by the rock. The rock was a natural magnet, and it attracted the iron tip of the shepherd's stick. So this is how the magnets were discovered. And such rocks were given the name as magnetite, perhaps after the shepherd's name. Magnetite contains iron. Some people believe that magnetite was first discovered at the place called Magnesia. Later on, the artificial magnets also started. Like we have magnets of different shapes. It was made by man. Like we have the bar magnet, cylindrical, ball-ended, horseshoe magnets. So in this first activity, we have taken a magnet tied with a thread. We have taken a cup in which we have kept the magnet, and over here we have the iron nail, or we can take any iron object. So we see that the iron gets attracted towards the magnet and it is raised in air like a kite. Magnetic and non-magnetic materials. There are some materials which get attracted towards a magnet, whereas there are some materials which are not attracted towards a magnet. So the ones which get attracted are called magnetic materials. The ones which are not attracted towards a magnet are called non-magnetic materials. So here we have a table. So iron, is it a magnetic material? Yes. Plastic? No. Leather? No. Now activity 3. Rub a magnet in the sand or soil. Pull out the magnet. Are there some particles of sand and soil sticking to it? We might see some slight pieces of iron which are picked up from the soil getting attracted towards it. Now what are poles of a magnet? In this activity, we've taken a bar magnet, we kept some of the iron fillings. We see that the iron fillings get attracted towards the poles. So there are two poles, one is North Pole and the other is South Pole. Now finding directions. Magnets were known to people from ancient times. Many properties of magnets were also known to them. So we see that there is a chariot with a statue of a lady that can rotate in any direction. It had an extended arm as if it was showing the way. The statue had an interesting property. It would always rest in such a position that its extended arm always pointed towards south. So that is the reason which made easier for people to direct the directions. So in the activity 5, we take a bar magnet, hang it with a thread. When we rotate it, it comes to rest in north-south direction, which shows that a freely suspended magnet always comes to rest in north-south direction. But later on, a device was developed based on the property of magnets. It is known as compass. A compass is usually a small box with a glass cover on it. A magnetized needle is pivoted inside the box which can rotate freely. The compass also has a dial with directions marked on it. The compass is kept at a place where we wish to know the directions, so its needle indicates the north-south direction when it comes to rest. Now, making your own magnet. We've taken an iron strip, we take a magnet, we keep rubbing in the same direction for 30 to 40 times. Now, after some time, you see that the iron strip or the bar of the iron acts as a temporary magnet. In the next activity, we have taken an iron needle using a bar magnet. We have inserted the magnetized needle through a piece of cork or foam. Now we take a bowl of water or a tub of water and we put it inside it. So you see that when you rotate the cork with the needle fixed in it in different directions, we see that it always comes to rest in north and south direction. Attraction and repulsion between the magnets. Now in this activity, we've taken two bar magnets. Whenever we bring the same poles towards each other, they repel. When we bring the opposite poles towards each other, they attract. Now, few cautions. Magnets lose their properties if they are heated, hammered, or dropped from a height. Also, magnets become weak if they're not stored properly. So, to keep them safe, bar magnets should be kept in pair with their unlike poles on the same side. They must be separated by a piece of wood, while two pieces of soft iron should be placed across their ends. For horseshoe magnet, one should keep a piece of iron across the poles, and we should always keep the magnets away from the cassettes, mobiles, television, music system, CDs, and computer.